So I'm presenting screen. Just tell me whether it is visible or not. So is it visible?
Yes, ma'am.
Okay.
Yes, yes.
So today we learn something about number system, which is used in our ICT in different equipments, computers, calculators. So basically, there are four number system: decimal number system, binary, octal, and hexadecimal system. Decimal system, the base is 10 and it is from 0 to 9, 10 digits, 0 to 9. In binary system, the base is 2 because the digits are 2, 0 and 1. So that's why the base is 2. Here in decimal, the base is 10 because digits are 10. In octal number, the base is 8 because numbers are 8. In octal number, we use 0 to 7. All right, just remember these things. Hexadecimal number, we use 16 numbers. So base is 16. 0 to 9, 10 numbers. And after that, two digits, 10 to 15. We use alphabets to denote them. All right, A, B, C, D, E, and F. A stands for 10, B for 11, then 12, D for 13, E for 14, and F for 15. So 0 to 15, total digits are 16. So base is 16. All right. Now, how we represent different systems, how we represent the numbers. So in decimal, we write 0, 1, 2, 3, 4, 5, 6, and so on. All right. In binary, if this binary is of 4 digits, 4 bits, not digits, 4 bits, only 2, 0, and 1 we are using, the combination of zeros and 1. Now here the binary representation is of decimal number. 0 is represented by 0000 because here the maximum number we are having in hexadecimal is 15. So decimal number it is written 15. How to convert, how to represent? Just the denotation, the decimal numbers are written till 15. Now 1 is represented in binary system as 0001. All right. 2 is represented by this, 3 is represented by this, and so on and so forth. The final 4, if there are 4 bits, so 4 bit, the maximum number is 1111, which is the representation of decimal 15. How we can represent them, how we can convert this decimal to binary, we'll see afterwards. Just go through.
And do we
Yes.
have to remember this or
No, no, no
it's
need
not?
to remember. No need to remember. You need to remember how to do the conversion, which we'll see later. Just after that, we'll see how to convert this decimal number to binary representation. All right. So you don't need to remember this. You need to how to convert the conversion process. You have to remember. All right. Now hexadecimal number it is represented by this. Up to 9, it is same, and this 10 is represented by alphabets A, then B, C, capital letters, okay, capital letters. And then octal, up to 7, it is same, but up 8 is represented by 10, all right. 8 is represented by 10. Then 9 is represented by 11. How it comes, we'll see later. So this is the representation. All right. This is not the ordinary 17, but it is 15, which is written as this in octal number. All right. If you solve it, it will come decimal 15. If you solve this, it will come decimal 15. If this F is representation of decimal 15. Now how they'll come like that? We'll see the conversion. Now see the conversion. Now if it is 13, which is in decimal, the simple 13, this 13. All right. How to convert this decimal number into binary? So what we do, we have to divide all this by 2 because the base is 2. In binary system, the base is 2, only 2 digits, 0 and 1. Like here, only 0 and 1. Here, 0 to F. So many notification denotations. And here, only 0 to 7, octal number, 8 number. And here in decimal, it is 0 to 9, 10 numbers. But in binary, only 2 digits, 0 and 1. Now you have to divide this 13 by 2 because we have to convert this decimal number, which is of base 10, to binary, which is having the base 2. So it is divided by 2. How many times this 13 is divisible? 6 times. All right. 2, 6, ja, 12. So what is the remainder? 1. So you have to write remainder here and divisor here, right? Now this 6 times, if you multiply 2, you will get 12. All right. Now similarly, you have to again divide this 6 with 2. How many times it will be? It will come 2, 3 just 6. All right. So 3. Quotient is 3 and remainder is 0. Here the remainder is 0. Now again you have to divide this 3 by 2 till when you will get remainder as 0 or 1. Till then you have to divide the quotient again and again. Alright. Again 2. So it will come 2 1 ja 2. 2 1 ja 2. Then the remainder will be 1. Alright. Now if it's not necessary to write here 2. All right, the remainder is already 1. So how many remainders you get till now? After dividing 13 by 2 continuously, 1, 0, 1, 1. Now how to write it? You have to, this is the least significant bit and this is the most significant bit. So you have to write like this, from down to up. So 1, 1, 0, 1, right? 1, 1, 0, 1. You have to write from downwards to upwards like this. All right. So this is the binary conversion of 13, which comes out to be 1101. Now if you convert this 1101 to again decimal number, there is a different process. All right, we'll see later how to convert binary to decimal. There is another example which is here to convert this decimal 25. Why this is written? Because it is a decimal number. All right, base 10. So you have to convert this 25 to binary. So what is binary? Base 2. So you have to divide this number 25, its quotient, again and again till you will get remainder as 0 or 1. The last remainder should be 0 or 1. So continuously you have to divide. It's a simple division process. Divide first 25 by 2. How much you will get? 2 1 ja 2, 2 2 ja 4. This is the quotient. So what is the remainder? 2 2 ja 4. 5 minus 4, remainder is 1. All right. Again, you have to divide it 6 ja 12. So remainder is 0. Again, you have to divide 6. So 3 ja 6. So remainder is 0. Again, you have to divide it by 2. You will get remainder as 1. 2 1 ja 2. Remainder 1. So like that, you have to again write in this way. Okay. Any confusion?
No, ma'am.
All right. Now the opposite, how to convert binary to decimal. So binary to decimal conversion is again not very much complicated. You have to write your numbers like this. All right, 10011011011. All right. Now what you have to do, starting from this least significant bit, 1. All right, 1. So here you have to multiply this with the powers of 2, because base is 2. All right, this is binary number. So 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, and so on. You have to multiply this numbers, digits, and then add them. All right. So first least significant bit is 1. All right. So it is multiplied by 2 raised to 0. 2 raised to 0 is 1. So 1 into 1 is 1, plus here 2 raised to 1. 2 raised to 1 is 2. So 2 multiplied by 1 is 2. So here it is 2. Again it is addition, 2 raised to 2 square, 2 raised to 2, that is 4. It is multiplied by 0. That means 0. Plus again 2 raised to 3, that is 8. So 8 multiplied by 1 is 8. So plus 8, so and so forth. So you have to add all these numbers and you will get this number. You can try with this also, which is here. You know that it is 13. So likewise, it is 2 raised to 0. That is 2 plus 2 raised to 1 into 0. That means 0. 2 raised to 2. That is 4. So you have to add 4. And 2 raised to 3. That is 8. So you have to add 8. So 8 plus 4, that is 12, plus 1, that is 30. So like that, you have to convert binary to decimal and decimal to binary. Second example is there, 11001. So here also, it is again a very simple simplification is done here. 1 into 2 raised to 0. That means 2 raised to 0 is 1. So 1 into 1, 1. Here 0, 0, the number will be 0. But the power is 2 raised to 1, 2 raised to 2. 2 raised to 3 is 8. So here it is 8. 2 raised to 4, that is 16. Multiplied by 1, it is 16. So add these numbers. 16 plus 8 plus 1 will come 25. That is here. You earlier we converted 25 to binary, and then this is the binary to decimal number. So that way you can solve the problem if it comes in your examination. Here it is simply they have converted all the digits from 1 to 10. So 1, it is simply 1 single digit. 2, it is like 1 0, because 0, 2 raised to 0 and 2 raised to 1, that is 2. 3, 1 1. 2 raised to 1, 2 raised to 0 and 2 raised to 1, that is 2 plus 1, that is 3. And here 4, 2 raised to 0, that means 1 is 0. 2 raised to 1, that is 2, is again 0. 2 raised to 2 is 4. So 4 plus 0 plus 4. 4 plus 0 plus 0, that means it is 4. So this is the conversion. The highest 3 digit will be 7. Highest 4 digit will be 15. All right. So likewise, you can remember some of the thing. Otherwise, it is simple to calculate. Here also they have binary to decimal. It is given here. How 11 is written, how 10 is written. So it's a simple conversion. By converting these numbers, you can get the result. Now the next topic is type of monitors. So here in number system, you asked earlier how to convert octal number or decimal number to binary and not binary decimal number. How to convert the octal number to decimal number. So the process is same. The difference is you have to have this base which is going to change. Like if it is octal, then it is the base is 8. You have to divide by 8 and you have to multiply the powers of 8 when you convert respective numbers. And if it is a hexadecimal, then base will be 16 in spite of 2 in binary. That is the difference.
Can you show one or two examples of octal and hexadecimal also?
It is not in a slide, but you just try your own. If you face any problem, we'll discuss it later. Because
There's
most,
also digits in the hexadecimal A to F.
Like if you are able to show one, we can try the rest now.
no, in slides it's not there, but I can explain you how to convert. Like,
Yeah, that will be nice.
okay, let me see an example. Because in your this UGC book, I don't find any, but in my book, it is written. Now, suppose there is a decimal number 153 and you have to convert in octal. So, octal, what you have to do in binary, what we did, we divide it by 2 continuously till we get the last remainder as 0 or 1. Now, in case of octal, you have to divide the number by 8 till you will get the remainder as from 0 to 7. All right, because these numbers can be represented from 0 to 7, you can represent the octal number. So if you divide 153, you'll get quotient as 19 first. Then you have to again divide by 8, you will get 2, because 8 to just 16. Now what is the remainder? 3. All right, now 2 is not divisible by 8. So what you write? 0. And what is the remainder? 2. So your remainders will be 1, 3 and 2. So how to write from bottom to up? Right? From bottom to up, you have to write the numbers. So 2, 3, 1. So 2, 3, 1 will be your octal representation. You will solve by yourself, you will get the answer. And if you feel any like difficulty, then we'll discuss again in the class. But the conversion is more or less same. You can just replace 2 by 8 if it is octal number, and you have to replace 2 by 16 if it is hexadecimal number. The process is same. The remainder in case of binary will be 0 and 1. Till 0 and 1 we have to divide continuously. In case of octal, the remainder will be up to 7. In case of this hexadecimal, it will be up to 15. But we don't write 15. We have to represent 2 digits by a single alphabet. Like 10, if it is, then you have to represent it by A, capital A. 12, 11 by B, right? So that is the difference only. But generally, they don't ask such questions because it becomes more tedious work in the examination. In engineering, they can ask such questions. Now, type of monitors or visual display units. So earlier, the monitors were of CRT, cathode ray tube types, then LCD come, and nowadays LED monitors. Now they are bulky in size. Some small, one of the small CRT shown here. It is like that. The whole cathode ray tube. Now this is the screen. So such a small screen, you need that much assembly. The whole tube, which is of vacuum tube, and all the cathodes and anodes are placed here. So it occupies very large space, as well as it is bulky, and the screen is not flat but curved, and screen is flicker type, not a very clear vision. The pixel size is also not much, so the picture is not that much clear, which we can see nowadays on LCD or LED monitor. Now LCD monitor, here it is, there are so many layers: glass, then polarizing film, then color screen, then liquid crystals are there, which gets charged and illuminated by the charge which they receive according to the signal. So there are so many layers in LCD, which is the liquid crystal display. And in case of LED, the light emitting diodes are used. There are so many LEDs are there on in LED monitors. They are very slim and energy efficient. Very less amount of energy or power is required as compared to CRT. You will receive very sharp images on such flat screen displays. Now there are some terms which you should know regarding the display. So one is pixel. Pixels are just a picture points, dots. So these picture points are having some, primary colors, dots, and they get illuminated as they receive the signal, and they are just measured in dot per inch. How many dots per inch is there? Like this. If it is 1 inch and the number of pixel here, it is 7 into 7, 49. 49 dots per inch. So this is its storage capacity. They are measured in dots per inch, pixel size. Now, what is resolution? Resolution describes that how many dots make the images, how many dots form the image. Like in television or computer monitor or any display devices, how many pixels are there to define a particular display. So if the number of pixels is more, then your image quality, picture quality will be better. So you need to have more pixel size to display a particular, to get the more refined image. Then refresh rate. Refresh rate is how many times that screen refreshes, how many times this display get refreshed itself. So in a 1 second. So that is the refresh rate. It is a rate, so that means it is measured in hertz. The frequency, how many times this display get refreshes itself. So that is the refresh rate.
This is in 1 second.
Per second, yes. If it is more, then your picture quality will be more smooth. You will not see the breaks in between the pictures. A very smooth display or smooth running of the picture will be there.
Okay.
Like here it is given in 1 second if the screen is refreshed 60 times. So that means 16 times per second the refresh rate will be. So this is the refresh rate, will you can say in hertz, it is 60 hertz. 60 hertz means 16 refresh will be done in 1 second. And respond time is how much time it the monitor takes to shift from one color to another color. So that is the response time. Generally, it is measured in milliseconds. Now we'll see some of the printers. Sometimes they ask about the printer in your examination, how many types and what type of ink they use, what type of beam they use. So basically, there are two types of printers, impact and non-impact. Impact means some impressions will be done on the page. So this impact type of printers are of two types, character printers and line printers. Character printers just make the characters to be on the page. So they are of again two types, dot matrix printer and daisy wheel printers. You don't have to go into much detail, but just remember the name and how the measurement is done. So in case of character printers, the measurement is done in characters per second. How many characters per second it prints. And line printers, they are drum printers. Sometimes they ask drum printers are what type of printers. So you have to, the correct option will be line printers. Drum printers, chain printers, band printers, all are line printers. The measurement is done by lines per minute. There are difference, right? If it is DPI, then dot per inch. PPM is page per minute. How many pages in 1 minute? How many lines in 1 minute? How many characters in 1 second? So you should remember where it is minute, where it is second, where it is inch. So character printers and line printers, they are impact printers. And non-impact printers, which doesn't impact or doesn't make any impression on the page, they are inkjet printers, laser printers, and thermal printers. This is the figure of one of the printer. Here they are impact printers. Such impressions are made by this keys, respective keys. So popular printers are LED printers, photo inkjet printers, and multi-function printers are also there, all-in-one printers. 3D printers are there, plotters are there to make the large sheets. 3D printers, some impressions are some more, HD type, so that you can more clarity, more functions are there, so you can see the picture more clearly. Three-dimensional effect will be there. So there are some pictures of some of the printers. Impact printers, dot matrix printers is something like this. Line printers is like this. Then laser printers, it is not shown here, but the laser printer uses laser beam, light beam. And inkjet, ink is used, but in inkjet, I think liquid ink is used in inkjet printer. And then thermal printer, photo and plotter both are thermal printers. So, and in laser printer, that powdered ink is used. So you should remember all those small things. Then it comes to types of software. So I'll go through this slide only today. Rest will go through.
Photo and plotter come under thermal, ma'am.
Yes. Yes. And plotter again, it is pan based or electrostatic, but that much detail they won't ask. They just ask this. This slide is important for you. Impact, how many types? Non-impact, how many types? That's it. Now, up till now, we have covered all the number system and hardware devices. The second part of a computer system is software. Software means some of the instructions, some of the coding, some of the programs. So there are different types of software depending upon the requirement, depending upon the function. So broadly, they are of three types: system software, application software, and utility software. So they are having different work, different functions. In system software, again, it is subdivided into two software, two types: operating system and language translators. Language translator means, language means Hindi, English, no. It's machine language or low level to high level to low level. That means the coding which you are doing, the instructions which you are providing, the machine has to understand those instructions. So for that, they need some translators. So all these are programs only. Operating systems, they are different companies having their different set of instructions. So those they have given some name like Windows, it is of Microsoft, Unix, Linux, Mac OS, which is of Apple, Android, which is of Google. So there are so many operating systems depending upon the companies which are giving that facility in a particular computer. And language translators, compiler, assembler, interpreter. They are again group of instructions which translates the high level language to low and then low to high. And then the second type is application software. Application software, it depends what type of set of instructions or program you want to run your depending upon what you need from the computer to perform, what type of functions you want. So as per the need, it's word processor, it may be spreadsheet, database. For accounting purpose, there are different software, page makers, Corel Draw, and many more. There are so many application softwares. Then utility software example will be, there are some to enhance the functionality, to protect your system from the unwanted corrupted files, viruses. So there are so many other programs also like antivirus, backup program, file manager, so on and so forth. So basically, you should have to remember system, what is system software, what is application software, what is utility software, and which type of programs comes under which heading. like operating system, what are the operating system, language translator, what are the language translators, and what are the application software, just name them. All right. And what comes under the utility software. Okay, we'll cover till here.
Browsers and search engines, no?
Browsers and search engines are application softwares. Different companies, different having different search engines, right? Like Android having different, Windows are having different software to browse. So let's see.
And Word, Microsoft Office applications and
Application software, all are application
yeah,
software.
Adobe, all those are specific purpose
Yes.
application software, right?
Yes. So let's see system software. System software, it is it's a communication between you and the system, the hardware. So how to apply your need, your requirement to the system, how to communicate with the system. So that need a system software, which is a link between the hardware and application software to manage all those things. So that is the master system, you can say, operating system. So it is application system, utility software, and other software to operate. It gives a platform for that. So, for example, the Windows, Mac, Android, Linux, and DOS, and all. Now, application software. Application software, how to apply, how to get the work done from whatever the computer system is having, how to use those software, which is system software. To apply those, we need to have application software. So they have to be for some specific tasks to perform. So any programming languages we have to use to make such software. All right. So they are also called, because these application software helps us. So you can say that they are computer programmer. Now application software makes your task or user's task easier to communicate with the system, to get the particular task to be done. So all these things can be done easily by using this application software. Like you have a photo, you want to edit that photo in some nice form, you want to change its color combination or brightness, or anything you want to add, anything you want to delete from the photo. So there is a system application software which is called Photoshop. So for a particular specific task, you need a particular application software. Now, application software are also of two types: general purpose or specific purpose. Now, if general purpose are those group of instructions or programming which a user can use for their general work, like word processing software, multimedia software, graphic application, gaming software. So if you are having such software, you can go through that particular task to be done. But specific purpose softwares are those who are made for some to complete some specific task. Like if the accounting software are used in particular field, like finance sector, in CAs, and that type of professionals, they need accounting software. Some banking purposes, they need different software. Education institutes, they need different software. And booking software like railways or airways, they need different type of application software. So just say, for example, it is written tally, they are used by accounting purpose. So there are some differences between system software and application software. Just give me a moment, please. Okay. So what is the difference between system software and application software? System software always run in the background. Whenever you apply something, whenever you do something, whether you are using some special application software or you are doing some browsing something, so this system software always run in the background. Because and this system software actually provides an interface to the user to apply some application software to complete some specific task. And system software, what are those? Operating systems, device driver, compiler, all those comes under the system software. And application software, MS Word, Excel, Photoshop, VLC Player, Notepad, Paint, and all to complete a particular specific task. Now, system software, we need low level language. Application software, you need high level language. C, C++, Java, and all. And low level language can be understood by the computer, and it is done by the translators, which we'll see in next class. Then utility software just manages the system to protect the system, to if there is any problem, to solve those internal issues by using some utility software. If there is some hang on done, some virus, some corrupt, the file get corrupted, you can retrieve your data by using some softwares. So this is the basically toolbox of your system. And you can increase the system's speed also by using some utility software. You can improve the performance of your system by using this utility software. One of the example will be antivirus. Some examples are given here. You make the system more secure. You can manage your accounts. Antivirus software you can upload to protect your system from the viruses or from any corrupt file. You can delete data. You can update, the software updates can be done automatically. You can clean up your system, and you can format any document or any presentation. So that way we cover here one more slide. Now, these are web browsers and these are the search engine. Search engine, these web browsers are part of search engines, respective search engines. So basically, the broader sense search engine, then under the search engine, the respective web browsers come. So what are the search engines like Google, Yahoo, and all, Baidu? They all are search engines. And these search engines make their respective browsers to access the different web pages or HTML files. So like Google made Google Chrome, Mozilla, Firefox, Netscape, Navigator. Through that, you can go to particular web page and find the, you can browse, you can access the net. So that way, I think you must have understood this. Computer languages we'll see in the next class. So for today, that much is enough, I think. Any problem in this?
No, ma'am.
Okay.